Good morning, ladies and gentlemen of Algebra 2. Welcome again to room 15 where learning never ends. And we have a few more of us here, 10 of us today, so that's an upgrade. So we're going to be going to section 5.4 today, which is solving systems of linear inequalities. And we start out with the essential question: how can you represent the solutions of a system of two or more linear inequalities? And so there's quite a bit packed into that just little sentence there, isn't it? So do you have any questions about that question? Well, I had a good question in the first period about this question, and it was from Braden, who asked, well, what's a linear inequality? Good question. So let's go ahead and talk about that. Is there anybody who has trouble remembering what a linear inequality is? Anybody? A little bit? Logan's not afraid to admit. Caitlin? Seth? Good. So a few of you raising your hands. Very good. So let's go ahead and sort of review that a little bit. And it says here's what the state of Texas in the vocabulary they ask us to do is solve systems of two or more linear inequalities in two variables. And so we're going to kind of go over a few things about what linear inequalities are and just kind of start on our unit here today. So it says explore turning a system of equations into a system of inequalities. And so what does a graph of a system of inequalities look like? And so that answers kind of the question about the question. Start with the system of equations. Y equals x plus 2, and then we have y equals negative 2x plus 1. And so if we take this first one, y equals x plus 2, and graph this on a coordinate plane, and so where do we graph this one? How do we graph this y equals x plus 2? We're going to recognize that our slope is going to be equal to 1, which is going to be 1 over 1. So where do we start to graph a line that we've been talking about and singing about and doing all kinds of stuff about? Where do we start our line? Y-intercept, okay? Y-intercept. So if there's one thing I want you to remember from this class, it's what? That very thing, right? Well, we start at the y-intercept. So we're going to start at 2, and the grids here are by 2's. So here we have it right here. And so we have 1, our slope is 1, so 1 over 1, what does that line look like? Well, it's going to be up 1 over 1, right? Up 1 over 1. So basically along this kind of trend. So we're going to have this thing right here in red like this. Okay, so that's going to be basically it. Okay, the next one we have is y is equal to negative 2x plus 1. So where does this next one start? At y equals? Start at 1.
Up 2 over 1.
And what we have is our m. Let me write it this way. M is equal to negative 2. So that's going to be negative 2 over 1. So where do we go for this one? We go down 2 over 1. So kind of steep. Down 2. These are by, I'm going to make these by down 2 over 1. So it'll be like this, won't it? So down 2 over 1. So it looks something like this. I'm going to go up 2. So something like this. Okay, well, that's going to have to be. I want to get a little more over to the right. I'm going to move that line just like that, right? That looks a little better. Kind of off down here, but you get the picture, right? And so now, so we've graphed the lines on coordinate planes, and so now we have this question here in part B is how many regions do the two lines divide the graph into? We have two lines and we divide this graph into how many sections? many regions do we have divided by these two lines? Four, right? Four things. And what I like to do, whenever I see this, it kind of just gnaws at me every year, because I don't like to use this word divide. I'm just going to cross that out. I'm going to replace that with the word separate. Why did I replace this divide with separate? Why did I do that? We went to an awful lot of trouble. Our textbook writers, they do a great job. And our district paid a lot for those textbooks, and I go ahead and rewrite the textbook. Why do I do that?
For it to be easier to understand.
Okay, Seth asked the question because it's easier to understand. Yeah, I think so. The reason it is, I'll tell you why. Because divide in mathematics has a very specific meaning, doesn't it? It means, doesn't mean as much this. I'll show you what it means. It means this thing right here on your calculator. That's what it means, right? And so I think if you put separate, so I hesitate to use the word divide or division in a non-mathematical sense during math class. Now, outside of math class, you'd understand, right? An intersection of two roads will divide that area intersected by those two roads into four separate corners of that intersection, right? We understand that kind of in our normal vocabulary. But in math class, when we say divide or division, I really want it to mean the mathematical definition of it, right? And so then it says, get to part C, consider what it means to replace these equal signs with inequality. And it says, first of all, replace the top equation by the inequality y is greater than or equal to x plus 2. So I'm going to go up here and change the symbol up here to greater than, I'm going to make it in red, greater than or equal to x plus 2. So I've changed that, okay? And then it asks the question, how is this different? And that explains. It means that for any x value, the solution includes not only the corresponding points along this red line, but also every point in the coordinate plane with the same x value that has a greater y value. So we have this y is greater than, and so we're going to include not only the solutions on the line, but also as solutions every point in that coordinate plane that is above that line. And so we're going to have this area too, that I'm going to shade in green. So the line itself and everything here that's shaded in green above that line. Okay, so that's going to be our solution set. And so next we're going to turn our attention to the blue line, and it says replace the second equation with inequality y is less than. So I'm going to go back here and make this a less than 2x, negative 2x plus 1. And so what kind of line do we need to have for less than? And do we have a solid line? We have a dashed or dotted line. So what I'm going to do is I'm going to change that. I'm going to go here to my eraser. I'm just going to go like this, kind of turn. Does that turn that into a dotted line? Kind of dashed line. Okay, good. And then it also says less than. So which way do we shade here for this one? Less than is shaded which way? Okay, we're shaded below. Below. And so what we're doing is we're shading, so we don't have, the solutions are not along this dashed line, but they are to the left or down from that. So I'm going to go ahead and shade this area like this. Okay, so now we've shaded below the blue line and above the red line, and so what area of the 4 is shaded both ways?
What area? The left side.
The upper left, right? So the upper left is this whole, it's going to be the upper left corner, so it's going to be everything that I'm here encircling in black, right? But not including that dashed line here. But everything in here, upper left, is part of our solution set. So that's basically what there is to it. You have questions on that? Well, the remainder of our class today, we're going to start to work on some of these exercises, and we'll call on some people to work over these things. Any questions on this? Does it look like it's pretty simple? Okay, let's go start working on these exercises. So now we come to this exercise set. We're going to go over these. We're going to spend today and tomorrow and then maybe even Friday working on these. But I want to show you something first before we actually graph this, and that's this. I'm going to go ahead and sort of review some of these symbols. This symbol in the upper right, what is the meaning of that symbol?
Greater than. Or less than.
Less than. So less than. But when we go ahead and graph linear inequalities, what I like to do is I want to reword less than. I want to change the wording of that. I don't want to make this less than, but I want to make this not equal to and less than. As we go over this the next couple days, try to remind me if I just say less than, I want to say not equal to and less than. And then what is this next one going to be here? Not equal to and greater than. Not equal to and greater than. And greater than. Okay, this third symbol here, what are we going to call that one?
Greater than or less than or equal to.
We're going to, yeah, usually you'd say less than or equal to, but I'm going to say equal to and less than. Yeah. And then similarly for this last one, we have equal to and greater than. Okay, before I explain why I changed that, there's one last inequality symbol that is not in these four. What is the last one? Anybody?
Is it like, I forgot what it's called, like the equal sign with the cross?
Yeah, so I think Seth is talking like this. So we have this, which is not equal to. And as a matter of technicality, this also is an inequality symbol, okay? But graphically, we're really concerned with these top four. Okay, why do you think I changed the wording on these, especially these last two? Why did I put equal to and less than, and equal to and greater than? Why did I do that instead of just equal to or less than or equal to? Why did I change the order of the wording, do you
So
think?
they're all the same format?
Yeah, but why did I do it? Oh, you mean so I'd have something up here too? Yeah,
Yeah, no,
possibly, yeah, possibly, yeah. Anybody else have a logic behind that? That's actually a good theory. Okay. Before you shade above or below the line, what do you have to do first? Before you shade above or below a line, what do you have to do first? You got to draw a line, right? You got to draw a line. And so, what decides what kind of line you draw? Okay, to know what kind of line you draw, you have to consider this first, don't you? Right? So when you change the order, you think, okay, not equal to, that tells you what kind of line? Dashed or dotted line, right? Equal to tells you tells you solid line, right? So when you can verbally consider it this way, you're going to have a better, it really fits the order of what you need to do. So that's why I did that. So I just want you to consider that, and you have questions on that as we go forward. Okay? Good deal. I appreciate Seth and TV coming up with some good things there. Okay. Yeah, and I do appreciate you two reminding me of that. That was really helpful today. Give me credit for that too. What I'm going to do with this number one is I'm going to go ahead and as a demonstration for the class, just show you what I would do for this one. And for this, we have these ones here, problems 1 and 2. We have these inequalities that are in slope-intercept form. If you look down to starting with problem 3, you have now like a different form you have to work with. But let's go and look at 1 and 1 here. So we have, for the first one, we have y is equal to and greater than. So what kind of line are we going to draw for the first one here? Solid line, right? So m, I'm going to rewrite m as, well, it's m is 1/2. And so where are we going to start this one? At -4. It's from our song, right? Where do I start the line? So up 1 over 2. So the thing is going to go like this. And then solid. Slope is rise over run. And then which way do we shade?
Down. No, up.
Up. So we're going to shade up above. And then here we have the next one we have is y is equal to and less than -5x plus 5. So what is our slope for this second one? Well, it's going to be, I'm going to put -5 over 1 to remind me that what? Rise over run. So we start at y equals 5. So we come to 5. And then we go down 5 and over 1. So down 5 over 1 looks something like this. Down 5 over 1 looks like this. So kind of a steep line, isn't it? So So it's going to look like this, solid line or dashed?
Solid.
Solid, so it'll be something like this. Okay, next. Are we shading above or below this red line? Below. So we're shading above the blue line and below the red line, so where's that going to be? Where's it shade in both areas? Which area is shaded by both above the blue line and below the red line?
The left.
So this left one right here, this left area. So I'm going to shade this in right here. And then I'm going to take, now I had a good question in this from Braden during the first period. And he asked, well, if you don't have colored pencils to do this, what are you going to do?
Just go there.
Yeah, what I would do is I would take your pencil and just kind of turn your pencil tip sideways and just kind of shade it lightly. Does that make sense? You can do that. So that's one way you can do it. And then the last thing it says give the coordinates of 2 points in the solution set. And so you're going to look at the solution set here. So what are 2 points that are part of this solution set here in the coordinate plane? What are they going to, well, 2 of them. What are 2 points inside that solution set? Negative 2, 2. So Caitlin says negative 2, 2. Let's check that out. So she says negative 2, 2. Is that right?
Yeah.
Yeah, so that's a good one, Caitlin. Thank you. And negative 4 also? Negative 4, yeah, negative 4 looks good because you're down 4. Yeah. Or negative 8, negative 4. 0, 0, right? So you just, there's an infinity of them. So we have some good ones right there. So what I'm going to do is call on somebody. Go ahead and work number 2. I'm going to call on somebody shortly to do number 2. How's that? Can you do that?
No.
All right, good.
No.
Call somebody.
What happens if both of the signs are the same for the top and the bottom?
If both the signs are the same? It'll be below both. That's what you mean, right? It'll be below both. Well, is it still going to separate that into 4 areas?
Yes, it is. Let's see.
Our chosen victim for number 2 is Dustin. So how's that coming along, Dustin? Pretty good. Go ahead, we have which way are shaded? So I have Dustin's paper here. Just kind of looking at it. So he has not equal to and less than. So for this first one, it comes to -2 and shade and goes ahead and draws that up 2 over 1, right? So something like this. And less than is going to be below. Okay, I'm going to go ahead and fill in some more dots to make that more complete dotted line. How's that? Does that look right? Yes, okay. Next, we have this one here, not equal to and less than -2x plus 4, so up to 4 here, and then down 2 over 1, so like this. And so, and shaded which way? Below the blue one. So common shaded area is in here, right? Okay, and then lastly, what are going to be 2 points within that shaded area below?
-4, 1.
-4, 1, let's check that out. So Seth says -4, 1.
Oh.
-4, 1 is up here, right?
It'd be 0 or 1, -2.
So 1, -2,
Or 1, -4.
1, -4, so 1, -4, oh, definitely, right? So that'd be right in here. So 1, -4 will be right here, okay? Everybody can agree with that? What's another point in here?
1, -8.
So 1, -8 down here. So 1, -8. Okay? That's not too bad, is it? Okay, I want to go ahead and look at problem 3. Problem 3 is this one right here. What kind of form do we have these in?
Not equal to.
Well, we have not equal to, but what kind of equation form do we have? Do we have slope-intercept form? We do not. So there's some more work to be done here, isn't there? And likewise for problem 4. So let's go ahead and change that to slope-intercept form. And for that, I want to have one of you help me change that to slope-intercept form. And that person we're going to call on is is Carly. So Carly, how are we going to change that top one to slope-intercept form? Because we got x minus 2 is not equal to and greater than 2. So I'm going to just rewrite this. X minus 2 minus y is not equal to and greater than 2. How do we change this to slope-intercept form? Get y by itself. Well, subtract 2 is not going to help us. We want this 2 to stay right over here. We want to get everything else, rid of everything else except that y. So we're going to work on the left side to get this by itself. This 2 is just fine where it is. What are we going to do to this left side? Did you get one, Carly, did you get one of the G-Dogs, the blue G-Dog shirts? Or you got the Slope Dude shirt? Well, if you got the blue G-Dog shirt, I want to show you something. Here's our blue G-Dog shirt, right? Here's the blue G-Dog shirt. What does it say on the back here? Add or subtract the x term and divide by the coefficient of y, okay? So now looking at that one up there, Carly, x minus y is not equal to, but greater than 2. What is the x term over there? Well, it's x. It's x. Are we going to add or subtract that?
Add it.
Okay. Is that x sitting over there, is that a positive x or a negative x? So what are we going to add or subtract it? Okay, what do we do to get rid of a positive x? Subtract, so we're going to subtract x. Thank you. Okay? So we subtract x. So we subtract x. So now we have negative y is not equal to and greater than negative x plus 2. And so the next thing is divide by the coefficient of y. What is our coefficient of y? Negative 1. So divide by the coefficient of y, so we divide by negative 1. So we divide everything by negative 1. What do we have? We're going to have that negative cancels out. So y is greater than. We take negative x divided by negative 1, that's going to be positive x. And then 2 divided by negative 1 is minus 2. Is that right? Okay, that is not right. What is wrong here? Anybody catch that? What's wrong?
Some of nothing to do.
No? 2 is good.
X should be
Sign.
negative.
Sign.
Yeah, what happens to the sign?
Flip.
Lives.
Yeah, the sign's going to change. Okay, so you caught that one. So who is the first one who caught the shit? TV. Okay, good job, TV. Do you remember that from Algebra 1, switching the direction of the inequality? Remember that, Carly? From Algebra 1 a little bit? Okay, good. But it's good to be, it's a hard thing to do. Once I went into an interview to be a math teacher, and what did I do when they questioned me about that? I forgot to switch the sign, and I'm interviewing to be a math teacher, and that happened to me. So, now, that eventually I got better at it, right? So let that be a list. Okay, good. So now we're good on this one. And next, so let's take this next one here. What I'm going to do is to get some mileage out of it, I'm going to call on somebody else to take care of this second inequality. And to do that, I'm going to have gonna have Logan.
Logging. Start logging.
Okay. Ooh, that's not what I wanted to do. Okay, I'm gonna do some more. Okay. Yeah, I think I'm. I'm rowdy, that's what I do. Let me get rowdy. Okay, very good. All right, let's go ahead and, so this second one, Logan, we got is, we have 2x plus 3y is equal to and less than 4. So what do we do with that one?
Aren't you gonna subtract off the 2x?
Yeah, subtract 2x, everybody agree with that?
Yeah, good.
Okay, so now we're left with 3y is less than and equal to negative 2x plus 4. Then what?
You could divide by 2, negative 2, or 3.
Divide by the coefficient of y,
So divide by 3.
3. So we have y is not equal to and less than negative 2x plus 4 over 3. All right? So I'm going to call on somebody else. I want you to graph those. I'm going to call on somebody else to graph. I'm calling somebody else to graph these. All right. Next, to graph this, we have Luke. So what do we have for this one, Luke? Did you do this one? You got it? You have this done?
I have a list for
Okay. Okay, so he has the, you have the x minus 2. Oh, you know how to graph the x minus 2? Okay, so what he has here is he has this one here, negative 2/3 x plus 4/3. So go to 4/3, about right here. Is that going to be solid line or dashed line?
Solid.
Solid. So down 2 over 1. So down 2 over 3. So down 2 over 3. So look like this. And we have to go up 2 over 3. So it's going to look something like this. That look right? and shaded which way? Below.
Down.
And then the next one we have is the x minus 2. So that can be dashed line or solid line.
Dash.
Dash. So we go up to -2 and we go 1 over 1. So it's going to be like this. And it's going to be dashed line. So we have that, and it's going to be shaded above or below? Below. So below here, below the red one, so below and below is going to be what? This whole area here. Okay? And so what are 2 points that are on that? What are 2 points that are on that, in that area there?
4, -8.
So 4, -8. So 4, -8 looks good. And where else?
0, -8.
And also 0, -8. That's the y-intercept, right? Or that's on the y-axis. So 0, -8. So what I want you to do is just keep it there, and we're going to come back to this tomorrow. So we're just going to leave it right there, and we'll see you tomorrow. Thank you.
That's